Welcome back. So this is our next lesson on the energy topic. We've talked about exothermic reactions, endothermic reactions, bond energies, and then how to use bond energy values to work out the energy change for a reaction, and then work out if it's exothermic or endothermic. In this next part, we're going to be looking at electrochemical cells. So make sure you've got the sheet, the title Electrochemical Cells, and the objective to investigate the voltage produced in a chemical cell. Okay, at the start, first question, what happens in an exothermic reaction? You all know the answer to this. So what happens in an exothermic reaction? Well, energy is released to the surroundings. So we've mentioned this. In an exothermic reaction, energy is released to the surroundings. So what tends to happen to the temperature of the surroundings? They would increase. So if an exothermic reaction, the temperature of the surroundings would increase. So we've mentioned if we burned a fuel, an exothermic reaction would happen, the temperature of the surroundings would increase. Or we mentioned chemical hand warmers, where the chemicals react and the temperature increases. What we're looking at today, though, is a different type of reaction, where rather than releasing heat, we're going to get chemicals to react and not just produce heat, but to generate electricity. So we're looking at chemical cells. So in a chemical cell, rather than a reaction happening to release heat, chemicals react to produce electricity. Okay, so we're going to get chemicals to react to produce electricity. And we're going to start with this very simple example that you may have seen before. Sometimes it's called a fruity battery. You may have heard it called a fruity battery. You may have done it at primary school, where if you connect a piece of fruit, a lemon, with two metal electrodes put into the lemon, they'd be then connected to a voltmeter. You may have done it where it's connected to a light bulb. And if you set this up with the two pieces of metal in the fruit, the light bulb will light up. Okay. This is a very simple cell, two different metals in the fruit, and they are producing electricity. Now, it says there when two metals in an electrolyte or salt solution are connected by a wire, a voltage is produced. This is a simple cell. So I've drawn a picture there. I do not have my GCSE in art, but you can see there the piece of fruit, two different metals, and then they're connected by wires to a bulb, and the bulb would light up. Now, that's a very simple experiment. You may have done it at primary school, where you could change the fruit and the bulb might light up brighter, or you could measure the voltage and you get a different voltage with different fruits, or you could change the metals and you get different voltage with different metals. Now, if you want to do it in a more organised way, rather than using fruit, we can use two different metals in an electrolyte. So an electrolyte is a solution that contains ions. And you might remember from the bonding topic that if a solution contains ions, it will then conduct electricity. So this is two different metals in an electrolyte connected to, now I've used a light bulb, but equally we could use a voltmeter if we wanted to measure the voltage. And if you remember from when we talked about the reactivity of metals in a previous topic, why are some metals more reactive than others? What are they better at doing? And you may recall the most reactive metals are better at losing electrons. They lose electrons more readily. So when we set this up with two different metals, electrons will flow from the most reactive metal. So let's say in this one, if the most reactive metal was on the left, electrons would flow from the most reactive towards the least reactive. Same on here, electrons would flow from the most reactive to the least reactive metal. Okay. And this is the basis of generating electricity. Two metals of different reactivity and electrons flow from the most reactive metal. Okay. Now we could obviously choose different combinations of metals, but the greater the difference in reactivity between the two metals, what's that going to create, do you think? If there's a bigger the difference in reactivity, there's going to be a greater voltage. So the bigger the difference in reactivity of the two metals, the bigger the voltage that's going to be created. Now if we were in school, we could then do an experiment. We're going to have a copper electrode and a voltmeter in an electrolyte solution, and we're going to connect a different electrode, an electrode X. We're going to change each time for a different metal, and then we will measure the voltage. So what we'd do, if we had the time, we would sand down the metal electrode just to make sure that there's no other metals on the electrode. We would then set the apparatus up, as we can see here. We'd use one metal, record the voltage, then we'd repeat it with different metals. Okay? You'll notice that the copper electrode will not change in this. We'll always use a copper electrode. The other electrode, we'll always try and use ones that are the same size or the same mass. We'll always use the same electrolyte solution. We'll use the same concentration of the electrolyte solution. Okay, so on your results table on the back, I've added an extra metal there at the bottom, which is silver, and we've tried this 6 times with 6 different metals. So we had copper and zinc, the voltage was 1.85 volts. Copper and copper, the voltage was 0. Try and have a think why the copper and copper had a 0 voltage. The magnesium and copper had a voltage of 2.40 volts. Iron, 0.70 volts. Lead, 0.32 volts. And silver was minus 0.25 volts. Try and have a think why the silver and copper cell created a negative voltage. Now, bearing in mind that we said the most reactive, the bigger the difference, in reactivity, there's going to be a larger voltage created. Can you put these metals, these 6 metals, in order of reactivity based on the voltage they've created? Hopefully you've got magnesium to zinc to iron to lead to copper to silver. Silver being the least reactive, magnesium creating the biggest voltage, being the most reactive. Okay, we'll look at those results again in a second, but let's have a look at the questions that we have here first. So in this investigation, what two control variables were used? So, have a think. And then we said the mass of the electrode, we tried to control, and the concentration of the electrolyte, or if you'd have said the same electrolyte. You could also have said that we used a copper electrode every time. Now, why do you think that the silver and copper cell produced a negative voltage? What could be an explanation? Hopefully you've realised that silver was the only one that had a negative voltage, because silver is less reactive than copper. Okay? Silver is less reactive than copper, or copper is more reactive than silver. That's why when we had the silver and copper in the cell, it produced a negative voltage. Now, it is possible to use these results to calculate the voltage produced when a cell was set up using a magnesium and an iron electrode. What voltage would this cell produce? So I'll say that again. We only connected copper and magnesium, and we connected copper and iron. Copper and magnesium gave a voltage of 2.4 volts. Copper and iron gave a voltage of 0.7 volts. Now, we don't even have to connect the magnesium with the iron to work out the voltage it would have created. Can you think, even without doing the experiment, how do I know what the voltage that the magnesium and iron electrode would have created? Again, if copper and magnesium was 2.40 volts, copper and iron was 0.70 volts, what do you think the magnesium and iron would have been? Hopefully you've realised it would be the difference. 2.40 minus 0.70 is 1.70 volts. Well done if you got that. Let's have a think about how we could do these then. So, we're going to work out the voltage that a zinc and iron cell would have created. Now, if the zinc and the copper was 1.85 volts, the iron and the copper was 0.70 volts, what would the zinc and the iron have been? Hopefully you realise it's 1.15 volts, the difference between 1.85 and 0.7. Try and work out the iron and the lead. So we'd have had the iron and the copper, which was 0.70, the lead and the copper, 0.32. The difference is 0.38 volts. We look closely at silver and zinc. Silver and zinc. Well done if you realised. The zinc and the copper was 1.85 volts. The silver and the copper was minus 0.25. So we'll be doing 1.85 minus 0.25 is 2.10 volts. So the silver and the zinc, if we'd have connected them together, they'd have made a voltage of 2.10 volts. Finally, which combination of metals would produce the greatest voltage? Which combination? What two metals would we use to get the biggest voltage possible? Hopefully you realise we'd use the one with the highest reactivity and the one with the lowest, the magnesium and silver. What would the voltage be? What voltage would that create? Hopefully you know that the magnesium and copper was 2.40 volts. Then we take away minus 0.25 volts. So it would give 2.65 volts. Well done if you'd figured that out. Now this is complicated, we've gone through it quite quickly. But what I want you to understand is the process of two metal electrodes connected to a voltmeter in an electrolyte, and then electrons are flowing. Electrons always flow from the most reactive metal. We can use any combination of metals, and electrons will always flow from the most reactive. Okay? It has to be in an electrolyte, which is a solution that contains ions. Remember we said, why does it have to contain ions? Hopefully you recall that allows the current to flow and it completes the circuit. Right? It's a very important principle, this, of how we can use a chemical reaction to generate electricity. So we're not generating heat like we talked about before, in an exothermic reaction where the surroundings get hotter. This is now just a reaction where two chemicals react and they're generating electricity. If you've got time and inclination, you might want to go out and you can buy some fruit and make your own fruity batteries. I know you'll be disappointed you're not getting the chance to do that at school, but this works well in fruit, two different metals in a piece of fruit. It has to be a piece of fruit that contains lots of electrolyte, lots of ions in a solution. Lemons are very good, if you can get lemons. And you might want to try this experiment. Any questions, contact your teacher. Hopefully you've understood this brief introduction into electrochemical cells. Thank you for now.